Welcome, everybody. My name is Josh. This is Modernizing Cloud Operations. I am a customer success architect here at Pulumi, which means that I work with some of our customers and help them ensure that they get the most value out of using Pulumi. So today's agenda: first, we're going to talk about how do you move out of cloud chaos, and then we're going to do a little bit of demo of a couple of Pulumi's products, which is our infrastructure as code and insights. Then we're going to talk about adding in security and some automation, and then I'm going to give you a demo of Pulumi ESC, and then we'll do Q&A as time allows, and then we'll wrap things up. All right, so let's get going. All right, so moving out of cloud chaos. Now, everybody has to start somewhere. For a lot of people, that is the console. It is convenient. It is like the easiest place to get started. But there's obviously some pretty significant limitations to using this approach. One is that it's really hard to recreate like environments. You have to go through the same series of clicks. Let's say if you want to create something, one thing in a development Google project and the other's your production, you would have to go and repeat that. That's going to be very, very slow and very error prone. And so, the answer to this is infrastructure as code. And there's two important ways that most infrastructure as code tools solve this pain. So all infrastructure as code tools, right? It's code, it's software, so it can obey a software life cycle. That means that you get version control. You can run the code. Obviously, it's code, so it all code automates a process. Because it's just code, you're going to be able to create modules in order to create reusable, non-repeated, sections of code. So that'll make the expression of whatever infrastructure you're looking to build more terse. Most infrastructure as code tools support some sort of testing or compliance, and Pulumi certainly does that. You can deliver these things through repeated automatable processes like CI/CD pipelines. And then, of course, you can also refactor or change that code as needed. And also, most infrastructure as code tools are indeed declarative, and Pulumi certainly fits that mold. In fact, they pretty much, unless you're using like the raw SDK of a cloud or doing things via bash script, almost all infrastructure as code is declarative. And so what we mean by that is that you only need to say what your desired end state is of your infrastructure. So I want this network, I want these compute instances, I want this storage, and then the tool will figure out what things need to be changed and in what order in order to get from what you have, which is stored in what's called a state file, to what you want. So essentially, infrastructure as code tools basically do a continuous diff between your state file and your code that is expressing what you want the desired state to be. And so that is really, really powerful because you don't have to say what order you want things in. You can say, this is what I want the end state to be like, and the tool will figure out how to get there. So a quick comparison between like how Pulumi approaches this problem and how some other popular tools on the market do. So Pulumi essentially combines two key features, and those are kind of the first two rows. It allows you to use general purpose languages to express your infrastructure, and it allows you to manage resources on any cloud. And so, like, why do you want to use general purpose languages instead of a sort of data centric type of thing like HCL or YAML or even JSON, right? So for simple things, right, HCL, YAML, they're fine. But as you get into more and more advanced scenarios, maybe if your organization is conducting a platform engineering effort, that's when general purpose languages are going to become much more useful. So one scenario that I like to talk about is that maybe your networking team keeps a list of IP addresses. They might be like CIDR blocks for networks, or it might be like some sort of allow list. Let's say they keep that information in a Google Sheet, right? Google Sheets has an SDK. That SDK is very, very easy to consume through a general purpose language like Python or TypeScript than it is through YAML, where or even HCL, where the underlying tool is going to have to do some stuff behind the scenes for you. And it's going to be really, really hard to get that data from an external source in exactly the way you want. But that is much, much easier in a general purpose language. So you can consume like SDKs for one. Second, like as you start building more and more infrastructure at your organization, you're going to need to do things like maybe conditionally create a resource, right? Or create a list of resources. That is much, much easier to express in it with an if-else statement or in a for loop than these sort of custom built functions that you see in the other infrastructure as code tools that don't use general purpose languages, right? If else is very, very easy to understand. For loops are easy to understand. But in these tools like, that are YAML based or HCL based, you're going to have to kind of create these like weird one-liners. You always have to look up the syntax, and it starts to become really, really unmanageable at scale. And so that's why Pulumi made the decision to use general purpose languages. And of course, like the ability to orchestrate resources in any cloud with the same tool is really, really valuable as compared to tools that only work against a single cloud. So, for example, let's say you want to spin up a GKE cluster so that's Google Cloud. You want to deploy something onto the cluster that's like Kubernetes resources. And then at the end, you maybe want to update your DNS and let's say Cloudflare, right? If you use an IAC tool that allows you to do things in any cloud, that tool is going to orchestrate all those dependencies in one place, right? So if you do something where you need to like tear down the cluster and recreate it, well, the IAC tool is going to know that all of those dependent resources, including the stuff that gets installed in the cluster or the DNS entry in Cloudflare, all of those things need to be recreated, and the tool will be able to figure out what to do in what order. So that covers the first two rows of this slide, the language and the resources. And then with the deployment model, Pulumi executes in a manner similar to Terraform. So Pulumi does not synthesize your program to an intermediate format like YAML or HCL. It's a very, very common question that we see. It actually, so if you create a storage bucket, we don't like take your program and then write it out to YAML and then run it somewhere else. We do it right there and then. We also don't have a centralized service that executes your program for you the way that CloudFormation does. So, and we also don't attempt to roll anything back like CloudFormation does. So hopefully that explains the deployment model. And then Pulumi also has some really good secrets handling. So we know what outputs of a resource are secrets. Like, for example, if you create a Cloud SQL cluster, we know that master password is a secret, and then we ensure that is stored. We only store the ciphertext in your state file, and then you can also mark things in your Pulumi configuration files as secrets as well. And I'll be able to show that in just a little bit. All right, so Pulumi has so little details of like what we support on the IAC side. So we have the following languages: Node, Python, .NET, Go, Java, and YAML. You can use Pulumi in any IDE. It's just a regular old program in whatever language you are. It's a regular old program in whatever language you're using. So all of your tools will work just as you would expect. Your linters, your IDE, your command line tools, your package managers, they all work with Pulumi programs just as you would expect. When I say any cloud, that includes all of the major hyperscalers, including, of course, Google Cloud, Azure, AWS. And then we also have like 170, it's a lot more at this point, different clouds and SaaS vendors that we support. So we have like a GitHub provider, a GitLab provider, Datadog, PagerDuty, New Relic, all those things are all supported. And so like, a lot of us are starting out in some measure of chaos. Maybe, one group is using, they're creating things through point and click in the console. Another group, maybe they're using infrastructure as code, but that infrastructure as code is a giant mess, or they're not using it consistently. Maybe another group in your organization is using some other infrastructure as code tool. And so like this is a very common, but also very unmanageable situation. So you have tons of cloud resources. They're all over the place. You don't know what you have. You don't know where you might. There's stuff that could be running that's running up a bill that you have no idea it even exists. There can also be security issues as well. And so, in addition to adopting IAC, I would also say that when you're kind of at the start of your cloud journey and you're trying to modernize your cloud operations, that a cloud inventory asset management tool is also very, very helpful. Something that will give you an idea of what even exists out there, so that you can get a comprehensive picture of what your cloud real estate footprint looks like. So Plumi also has a solution for this. It's called Plumi Insights. Essentially, the way it works is, first off, any cloud resources that you create and manage with Plumi infrastructure as code are present in the Insights UI. So you have that, and then you can also supply an account where Insights can, you basically say, okay, here is my like AWS account. You give it some credentials, and then Insights will scan that account and find all the resources there, whether they're managed by Plumi or not. And so in this way, you can start to get a handle on what exists. But even from there, you can apply policies to those discovered resources and figure out, like we have, we have a virtual machine that's running an outdated image of an operating system. And so that might be a security issue. And so from there, you're going to be able to discover which of your resources are out of compliance and then bring them into compliance. All right, so let's do a demo of the things that I just discussed. All right, so I am going to share my screen once I shuffle a few windows. All right, I need a terminal window, which I'm going to grab. So please be patient. All right, so let's grab that terminal window. Let's maximize it. Let's get that font nice and large. Don't worry, I know I'm not sharing my screen yet. I just need to move some directories. All right, so let's share my screen. All right, screen is shared. So let's do a demo. Okay, so I am in a directory. I'm going to make a fresh directory. We'll call this live demo container gcloud. All right. All right, so there's nothing in this directory. I'm going to initialize my Plumi program by running the Plumi new command. And then when I do this, I have the option of entering an AI prompt, which is really good choice if you are doing something that's maybe a little bit less common. Or I can use one of Plumi's existing templates. For this demo, let's start by using a template. And so I'm going to go, so I'm going to deploy a Cloud Run workload. So let's go container, GCP, and let's do this one in TypeScript. The steps are relatively the same, by the way, no matter what kind of what language you're using. They're very, very similar. I'm actually going to make sure I have. Yeah, I'm going to shuffle that. Okay. So, by the way, if someone could chime in on the chat and make sure that you can see everything fine. It looks all right on my screen. But if you need to be larger or something like that, just let me know. Okay. So now I'm going to give my Plumi project a name. By default, it will take the containing directories name, so that's fine. It's going to ask me for a description, and I can, you can give a description, but the default is fine for purposes of this demo. Then it's going to ask me to create a stack. So a stack is essentially an instance of a Plumi program. The most common way to arrange stacks is by doing like dev, QA, and prod, or you might have like a primary and disaster recovery, something like that. But usually like dev, staging, prod, that's how you're usually going to arrange your stacks. It's going to ask me to use a package manager. So npm, the default is fine. And then it's going to ask you some questions. So these questions are specific to this template. And so one of the cool things you can do with Plumi programs is you can make your own templates. And so this is a way that you could create a sort of base level of self-service in your organization. So I'm going to give it project. Okay, it's going to ask for the region. The defaults are all fine from here on out. Okay, so now it's going to install my dependencies. It's going to essentially clone a repo locally, and let's see what we have once it's done. Okay, cool. So I'm going to start VS Code in this directory, and here's VS Code, and I'm going to make this larger for folks. So hopefully that's large enough. Let me know if you have any trouble seeing this. So what do we have here? All right, well, this looks a lot like a normal TypeScript Node program. And if we go into index.ts, this is our Pulumi program. Some of the highlights. So the way that you import the providers, the way that you control resources in different clouds is you just add a reference. So like if, for example, I wanted to add some Cloudflare resources to this, I would just go npm I at Pulumi/Cloudflare. And yep, so that would add the Cloudflare provider, and then I could go import star as Cloudflare from at Pulumi Cloudflare. And then if I wanted to declare some Cloudflare resources, I would go const my Cloudflare thingy equals new Cloudflare dot. Let's just pick something like a DNS zone, DNS record or something. Okay. And then I can give it a name, my DNS record. So every Pulumi resource has a name. Notice, by the way, that I get autocomplete as I'm writing this. And so we can give it a name. It would be like foo.example.com and a TTL, which will, I don't know, 800. It's probably good to write. And a type, which is probably a string. Call it an A record. This obviously isn't my zone ID. Right. And then I would be able to, these are not real values, obviously, but just to give you a sense of like what the authoring process is in Pulumi. And again, like if TypeScript is not your chosen language, it's going to work exactly the same way that any other, let's say, Python program would work for you in Visual Studio. Okay. So some more of the things you can do. So this is how you declare a resource. There's also options on a resource. So every resource has the same the same structure when you declare them. But there's also a bunch of different options. You can, for example, prevent things from being deleted. There's a lot of stuff you can do. You can assign things to a specific provider. That's how you do like multi-region setups. And there's plenty more in the docs about how that stuff works. So in this block here, we are reading from our stack configuration file that is right here. If you want to add a configuration value to a Pulumi program, you can go like Pulumi config set. Let me clear this so it's a little easier to see. So you go like Pulumi config set foo bar, and then it added this line here. Now I can also do, you can also store secrets in your config file. So you can go Pulumi config set foo secret. Let me just pass the -- secret flag, foo secret, bar secret. And then notice that when I do this, that you see how this doesn't get added as plain text. So this is actually encrypted. So excuse me, because of this, you can commit this file to version control. There's no risk to doing that, because again, as long as you mark your secrets as secrets, we know they're secrets, and you can commit this file to Git. So in here, I'm reading from my config file. I'm reading some more config down here, and then I start creating a bunch of resources. What this program does is it creates an artifact repository, and then as we scroll down, it builds a Docker image, and then creates a Cloud Run service to run the container. So if I go Pulumi up, that's the command that will deploy my resources. Whenever I do this, it's going to give me a preview of what it intends to do. I do not have. I need to do gcloud auth login, and I'm gonna cheat. because I don't remember how to set the default credentials. Let's get that off the screen. Let me clear this stuff. So you should be seeing a blue screen. That's because I am logging into Cloud. And I also need to set, how do I set? I'm asking ChatGPT right now because I don't remember this offhand. How do I set default app credentials for the G-Cloud? G-Cloud CLI. I think it's just a flag, and I don't remember the syntax because I don't often. Here we go. All right, so back to our. Just gonna run this real quick. All right, so that should do it. I should have some permissions now. So, and I also, let's go Plumi up, and hopefully this works. It has been a while since, there we go. Okay, cool, great. So I have credentials. It tells me what it's going to do, and it's going to create these resources. And if I like that, I can say yes. And then it's going to do its thing. This does not take very long to spin up at all. But in the meanwhile, maybe I'll check the chat, see if is everybody following along. Let me know in the chat if you are following along. This is making sense. Let me know if you have any questions on the Q&A tab. So you see here, it's doing its thing. It's doing a Docker build to build the image. Now it's creating the Cloud Run service. And it's also worth noting that all the way at the end, we have this export. So this export in a Plumi program in TypeScript will make what's called a stack output. Here, I'll highlight the line. And what that does is that allows us to grab a value from our Plumi program from somewhere outside the Plumi program. And in this case, it's going to be the command line. But you can also use stack outputs as a way to create sort of multiple. So like for larger architectures, like you might do your networks in one stack, and then you use a stack export to bring that into another stack in another Plumi program. And that's how you do like sort of references between Plumi programs. But for this example, we're going to use it for the command line. So again, this Cloud Run service is doing its thing. And it shouldn't take too long. Cool. All right. So now we have our output. And I can click this URL. And as you can see here, we are getting our hello world, which is exactly what our app does. Cool. All right. So that's a simple example of how Plumi IAC works. Now, what about, I also mentioned Plumi deployment. So let's take a look at how that works. So over here, this is Plumi Cloud. This is our SaaS product. So in our SaaS product, it does a lot of things. But if you want to see how Plumi Insights works, we can go down here to resources. I'm actually going to switch to a different org because there's more resources in here. Whoops. Let's go to resources. Okay. So what we can do here, so this is the basic Plumi Insights interface. We can take things and first group them by like say what's managing them. And so these are the resources that are managed by Plumi, and then we have stuff that's like managed by something other than Plumi. If we go into this, we can also group it, let's say by type. So the type will tell us the type of resource in our non-Plumi managed resources. And then we can sort it by name. So you can see that there's a lot of ECS task definitions. That's kind of a normal thing because they just kind of get generated. In our case, a lot of this stuff is generated by things outside of like the IAC itself. So for example, you might be running like a Kubernetes cluster, and that might be creating a bunch of like application load balancers or things like that. So that's kind of normal. But again, this like gives us some visibility into like what we actually have out there in the world. I can even go into these things, look at their details. I can click into them, and then it will take me to a detailed view of the resource. I can also go through the different versions, so I can see how this thing changed over time. And I can also apply policies to this to ensure that these things are in compliance. And I can also see what policy violations exist. So this is like a list of all of the resources that are not in compliance with various policies. And so that's really powerful stuff. All right. Oh, and so it's also worth noting that right now we do not have a Google Cloud account scanning yet, but that is definitely on the roadmap and should be happening in due time. All right. So, and again, if you have any questions on anything you saw, please hop on over the Q&A tab, and I will try to do my best to get you an answer. All right, so that's Plumi ISC and Insights. And again, so that the point here is that this is going to get you from like, we have a mess today to we at least know the scope of the mess, and we are starting to use infrastructure as code going forward as a way to make sure that we don't make more of a mess. So this will help you really get a handle on what's going on in your cloud environments and ensure that you're not making anything any worse. 1 second, please. For context, I live in Philadelphia, which is on the east coast of the United States. And there's quite a bit of pollen in the air, and my house does not have central air conditioning. So there is quite a bit of nastiness blowing in through the fans in my windows. And so I appreciate everybody's patience with that. Okay. So another problem that you're going to see, right, is security, right? And we all care about security. The first issue, actually, you know what? I got a really good question from Ezra, and I'd like to bring this up on the screen real quick. So, is there a way to reverse engineer exiting cloud resources into Plumi project as code? Okay. So, how do you get from I have stuff in the console and I want to put that under infrastructure as code? That's a great question. So today, I'm actually going to close this question. I'll show you what this looks like in the docs. So let me shuffle some windows again. I'll open my screen. So Plumi has what's called the Plumi import command, and that's what allows you to import a resource. And so the format for that, so this is in the docs. I will add this as the answer to that question and share it with you all. So this is answered and this is published. Okay, so you should be able to see this link in the Q&A tab. The Plumi import command is what does this. You can import resources on a one-by-one basis. If you want to know how to import something, you can go into the docs. Oh, let me slow down a little bit. So this is the Plumi registry. This is where the detailed API docs are for all the different clouds that Plumi IAC can work with. So let's say we want to import a service account. All right, so I can go in here, search for service account. So the service account is right here. And if I go down to this import right here, this will show me an example of how to import a service account. And when I do this, by the way, it's going to bring the state of the service account into my state file. And it's going to give me the code that I can just paste into my Plumi program. So that's how importing works. And then you also, the import command supports a JSON file. So if you want to import things en masse, you can do it that way. Now, wouldn't it also be nice if you were able to import discovered resources from Plumi Insights into Plumi infrastructure as code? Wouldn't that be nice? And I will just leave it there. But stay tuned would be my advice, if that sounds interesting to you. Okay, so that covers the answer to that question. If you have more questions, please ask on the Q&A tab. Let's go back to the slides. So now we're talking about security, right? which is a concern for everybody. And a lot of us have this situation where we might have secrets that are just repeated all over the place. And excuse me. So you might have some secrets are in one cloud environment. In this slide, I have it done as Google Secrets Manager and in a dev project. Maybe some other secrets are in some other project. Some are going to be on your developer devices. Maybe people have API keys or things like that. And you're going to have to repeat those things again in your CI/CD pipelines. And this is bad, right? Because not only are the secrets themselves all over the place, right? That makes it really, really hard to rotate them, because if your secret gets released into the wild, if it's like an API key, you're gonna have to retire that old API key and create a new one. And so, how do you get that new value out? How do you make sure that everyone knows to use the new value? How do you keep your applications running if you have to rotate an API key and you can't redeploy the application very quickly? So that's the problem with rotation. Then on top of that, not only do you have secret sprawl, right, but you also, even if all that stuff is all stored in cloud, but it's all in like a bunch of different places, or even if you have to grant access to a ton of different people, now you have permission sprawl. So you don't, least privilege is a thing. You really want to make sure that you only give the necessary access to the necessary principles. And so, secret sprawl and permission sprawl just leads to a giant headache. And so Pulumi has a product called ESC, and we believe this is a better solution. I appreciate everybody, tolerating my very poor graphic design skills, but hopefully this slide illustrates how Pulumi ESC works. So within Pulumi Cloud, an administrator will define what's called an environment. That is just a YAML file. I will show you an example of what an environment looks like. Maybe I can even pull one up on the screen real quick. In fact, I will. So what does an environment look like? Here's an example from the docs. I will drop this into the chat, and I will also share my screen because I'm not sure if you're able to see that. So let me just pop on over, share my screen with you. Okay. So this is what environment looks like. I can even make it bigger. Whoops. And I made the wrong thing bigger. So this is it. It's a YAML document where essentially you're going to define some like OIDC and then like some secrets that you're going to look for. And then you can take those secrets and output them as different things. They can be environment variables. If you want to run stuff from the command line, you can output them as directly as Pulumi infrastructure's code config values. So that's really, really helpful when you're using Pulumi at scale. I also lost my chat here. I want to make sure I'm following up. Okay. So it seems like the chat's pretty quiet. But again, if you have anything to add, please let me know in the chat and also hop in that Q&A. All right. So the way it works is you define an environment, and then when someone wants to consume some secrets, essentially they authenticate with one place, and they are authorized in one place. So that's Pulumi Cloud. So you use your Pulumi Cloud credentials, and then Pulumi Cloud can grab all of these different secrets from all of these different places or temporary OIDC credentials and return them to the user for them to use whatever way they need to. And those secrets are never written to disk. So this is a much more secure way of handling things. And Pulumi ESC, it integrates with all of the major kind of products that you see out in the marketplace and all of the cloud, the managed services in the cloud. So this works with a lot of different things. All right, so let's do a demo of that. So I'm going to give you a very, very simple use case. I'm going to hop on over to my command line, and I'm going to shuffle some windows again. So I'm going to share my screen. Okay, cool. So I'm going to clear the screen. So what I'm going to do right now is I'm going to log out of all G-Cloud stuff. And I got to get rid of my ADC credentials. Yep. So we're going to revoke that. So now I'm going to try to run, let's list my GKE clusters. So that's G Cloud Container Clusters list. Now this should fail because I have no credentials, right? So I don't have any credentials on my machine. But what I do have is I have an environment that is defined in my my Pulumi organization. So go into Pulumi Cloud in environments. Here's where I set up the environment for this workshop. So I'll take you through this environment. In fact, let me grab it and then I'll stick it into Visual Studio Code. Oops. And let me get the YAML highlighting. So this should be a little easier to read. All right. So this is an ESC environment. So we start with the values. So what this does right here, this block, this will, there's a little bit of setup that I'm not showing, but I set up an OIDC provider in Google Cloud. And what this does is this allows, it allows Pulumi Cloud to log into my GCP project. Let me also just make sure, is everybody able to see this? Everybody able to see this okay? Yep, okay, I just want to make sure. All right, so so this will allow me to assume, allow Pulumi Cloud to assume an identity. And then what this will do is this will return the necessary credentials as temporary environment variables or as Pulumi configuration. So what this will do is this will, so when I open this environment and run a command under this environment's context, I will have these temporary credentials and then they will disappear as soon as the command finishes running. So let's try that out. So the way you do this is you go Pulumi env run, and then the name. So this is essentially the path to my environment. It is a little bit wordy, so I apologize for that. And then I do -- and then the command that I want to run. So I'm going to run gcloud container clusters list. Cool. So now I actually can run these commands. And then there's stuff that you can do from here that's a little bit more advanced. So environments are allowed to import other environments. So you can essentially combine, let's say, OIDC credentials with, maybe we have a kube config, right? And so I can use that to do secure and convenient access to like my Kubernetes clusters. So I would be able to, for example, do something like, Pulumi env run and some other environment. And then I could do something, if that environment can combine both my OIDC credentials and a kube config, I could run like kubectl get pods or something like that. And so, that solves, I really, really like using ESC from the command line for Kubernetes cluster access. It makes that much, much, much easier because kubectl is absolutely awful at managing multiple contexts. I find it to be very, very difficult to do. So if you have any questions, please ask in the Q&A. I'm going to come back to that very soon. In fact, I'm going to check real quick now. Do we have any questions in the Q&A? No. So I can only assume that I have perfectly explained everything so far and everyone is following along. But if that is not the case, please don't hesitate to ask a question in the Q&A. So and the other thing you can do with ESC is combine it with Pulumi programs so that you don't have to give out either secrets or even permanent login credentials to any of your environments, including with Google Cloud. So I'm going to show you how that works now. So if I go back to my Pulumi Cloud program, let's say I want to tear down all of this infrastructure. And so the command to do that is Pulumi destroy. So I don't have any credentials on my machine for Google Cloud, right? Remember, because I logged out. So I go Pulumi destroy, and then this is going to fail because it can't reach Google Cloud. So if I try to do this, it's going to fail, right? It says, hey, you don't have any credentials. So what I can do is I can integrate my ESC environment with my Pulumi program. And this is really cool because like you can use this and like this makes it really easy especially to do things like CI/CD, because your CI/CD pipelines will be able to automatically grab these temporary credentials as long as, and all you have to do is supply a Pulumi token, which is how you authenticate against Pulumi Cloud. So if I go environment, and then I add my environment here by name, which I have here, add that environment by name. And so if I go clear and I go now Pulumi destroy, my Pulumi stack will have credentials. All right. So that is going to work. It would have failed by now. Yeah. As you can see, everything's being teared down. So now I have those credentials. And so like, this is, again, like this is really, really powerful stuff. This is a much, much better way to manage your secrets compared to like managing them manually and having to grant everybody access. So that concludes the demo for ESC. Let's hop on over to Q&A. So we have a question from Kartik. Can we have Pulumi ESC in a do-it-yourself backend like GCS bucket? So what Kartik is referring to is, so if you want to use Pulumi in an open source way, you can store your state file in G Cloud buckets. We also support backends in Azure or Pulumi, or excuse me, Azure or AWS. Similarly, in their object stores. However, Pulumi ESC requires a commercial Pulumi Cloud account. So no, we do not support DIY backends for ESC. It's kind of impossible to do because Pulumi Cloud is doing the logic of getting your reaching out to your cloud, so it kind of doesn't really make sense to do that in the DIY way. If you so ESC though is quite affordable. It's not terribly expensive. So I would definitely encourage folks to maybe sign up for a Pulumi Cloud team account, or even try it with the free Pulumi Cloud. We have some level of usage for it. I don't remember the quota offhand, but you will definitely be able to try out ESC yourself for free. So that answers that question. Let's check the chat. Okay, it doesn't look like anyone. It looks like we're following along okay, or at least if you aren't having trouble following along, you're not saying anything about it. So like, where can you go from here? Well, there's a lot of different ways. So with Pulumi IC and using it in conjunction with Pulumi Cloud, you can build out a lot of different things. So this slide shows an example on the left-hand side of like, this is how you do a component in Pulumi. It is done in Python. But it's essentially just subclass a class. It's essentially the same thing in all the supported Pulumi languages. And then from there, people can consume those modules directly in code. You can set up low-code YAML methods of doing this, or you can even set up templates in Pulumi Cloud that will give you the sort of like a higher level of self-service, and even moving towards an integrated developer platform, or IDP, as you may have heard mentioned. And so in conclusion, Pulumi has these three products. They all work together in the same way to help you achieve the sort of dream of platform engineering. Again, those three tools are Pulumi Infrastructure as Code, which allows you to define resources; Pulumi ESC, that allows you to securely handle secrets in a way that your developers are going to love. And then there's Pulumi Insights, which allows you to get a full picture of your entire cloud footprint, and to run policies against those discovered resources. And so, by using the Pulumi platform, you're going to be able to sort of achieve that platform dream, where you have, excuse me, the infrastructure team is able to create a platform that encompasses the security that the security team needs, and that is going to be easy for developer teams to consume. And pardon the pause, I'm just checking. Okay, and then we have one more question that I'm going to throw up on the screen. From JavaScript, are we able to add components like we do in Angular? In Terraform, we have a root directory to point to subdirectories. So if I understand correctly, what we're asking about here, I will grab screen again. And so I think what we're talking about here are Plumi components. And so that is covered. So they're called component resources, and that's kind of what we're defining right here. So yeah, not you can point those things to a subdirectory, right? So you can import those components if you want to. That's one way to do it. Or you can also publish a library of components, and you can publish that using the standard packaging tool of whatever language you're using. So if you're using TypeScript or JavaScript, you can create npm packages that contain different Plumi components and share those with your team as a way to create a level of self-service. All right. So if there are no further questions, we're about ready to wrap this up. So folks, please continue your Plumi journey. If you liked what you saw today and were interested, you can sign up for a free forever individual account and create some infrastructure. You should also be able to try out Plumi ESC as well. There is a link to sign up for a Plumi Cloud account that is pinned in the handouts tab, or I think you should see it everywhere. So sign up for a free individual account if you have not yet done so. If you have done that and you haven't yet joined our community Slack, that's a great place to get your questions answered as you go on your Plumi journey. So, of course, once you sign up for a cloud account, don't just sign up, try using the product. We think you're really going to love it. Once you've done that, join the community Slack. That's at slack.plumi.com. We have a couple channels in there that could be of interest to folks attending this workshop. Those are Google Cloud and Platform Engineering. And then if you want to learn more, join us for an upcoming workshop. We will send you an email that will let you know about upcoming virtual events. And if there's something in there that feels relevant to what you want to learn about, please join us. And with that, I would like to thank everybody for taking the time to spend with us today. I hope you're all well. I hope you have a good rest of your day. And again, thank you so much for taking the time to spend with us and learning what we were able to present. We hope to see you again soon. So long, everybody.